Okay, very good morning, good evening, depends on where you are. I think I'm this week tutorial, I will take some time to reflect back on the interrupt. We studied about the interrupt in the previous lecture. Interrupt is it's a very it's not to say a very advanced topic of discussion. If you've been playing around with microcontrollers, you would have knowledge on this area. Uh, but I think this week I will try to bring up something that combines I/O implementation. A lot of you are facing problem with the configuring the I/O based on the lab and the quizzes. So I think I will just try to take something out and discuss. Okay, so this week I think we will discuss on the interrupt. Some of the codes we will investigate. Some of the codes very similar to your lab implementation. We are not going anywhere, beyond LEDs. So it's basically just blinking LEDs and so on and so forth. But after this tutorial, you should be able to understand at least the interrupt and the blinking part. How do we configure the IOs and so on and so forth. IO has been investigated in previous lectures. Please check out once again. It's very important. But for your benefit, I'm just going to repeat this once and for all. I think if this tutorial you really need to go through in depth. If not, it'll be very difficult for you to answer questions in the finals. Okay, the final schedule is already out, online version. Please take note on this topic. Now let's assume that you have a MSP 430. There's a lot of models, different sets of model that some I've never seen before. Let us assume that it is a generic MSP series. Then you have a single LED connected to one of the ports. Okay, and this LED is active high. It means to say that if you put a 5 volt on the pin, it will on, and if you put 0, it will off. Okay, now let's assume that pin 1 is 5 volt and pin 1 is either 0 or 5. This is digital pin. Okay, and port 5 is connected to the button. Port 11 is connected to the LED. Okay, normally we express it like this. Okay, port 1.1 means to say that port 1, pin 1. If port 1.5 means to say that it's port 1 and it's the 5th pin. Okay, normally if you buy an video system, whether it's Arduino or whatever, it'll be written. All right, MSP is if you buy Arduino, normally the convention is they do not use this port system, but in MSP, they have this port system. So port 3.2 means port 3, the second pin. So the whole MSP normally is divided into different groups of ports. Okay, you have port A, port B, port 1, port 2, port 3, and so on and so forth. You could be familiar with this because you're doing labs. Okay, now let's assume that you have port 1 pin. Okay, you have port 1.1 is connected to a LED and then grounded. Okay. Okay. Now let's assume that you have a port 1.1 is output connected to the LED, and port 5 it's a button. Okay, it's a button, and this button is normally low. Okay, normally low. You connect it to a button, and once you press it, it'll be grounded. Right. So now look at this figure. This is the code that you have. This is the code that you have. This is the scenario, and this is the code that you have. All right. Now, if the question normally finals, one of the question will be difficult question. You will have a code type of question, and this is how it looks like. Probably they will make some mistakes in the code, and they will try to ask you to rectify it, and so on and so forth. Something that's relevant with your lab also. So I strongly suggest, even though you are doing with your partners, okay, 2 person per lab or whatever, please try to learn it, understand it, and not just to just to memorize it. It's very dangerous to study this kind of topic by memorizing. Look at the first sections, okay, these sections, 1, 2, 3, 4. Okay, the first section is configuring the I/O. Okay, this is with regards to your I/O lecture. Just that now we are investigating interrupt, but we need to understand 6. Okay, the I/O. So port 1 direction means to say that port 1. Okay, you configure. You remember I taught you guys how to do bit masking. Okay, so this n equate to negate of whatever this value. It means to say that this is a mask reset, and this is mask set. Okay, it means to say that you only affect that pin that is selected, whereas the other pins you do not touch. Now P1 direction means to say that you set the port, the first pin as output. Now why do you set the first pin as output? Because this is connected to the LED, okay, and so on and so forth. All right, I remove actually from the original question. I remove all the comments because I like you to actually go and study. It is something like a template. All right. The port 1 is configured as the interrupt pins, and you have an LED connected, more or less something like this. All right. And the question is, what does the code do? All right. So this could be a question. It could be a long question, 10 marks or whatsoever, in which each line will give you 1 or 2 marks. So you're having out of 50 points, 50 marks, you're talking about 10 points. Okay, with this code question, very important for you to understand. Now, the question previously question pin port 1 direction is you use the bit masking to set this as 0, 1. So this is an hex 0, 1. So if you expand this to binary, can you you take out a piece of paper, you expand this to binary, it will be equal to 0, 0, 0, 0, 0, 0, 1. Okay, it means to say that I only set this register, I only set the final bit as 1. Now 1 means you configure that particular pin as output and the rest as input. Okay, I repeat, this kind of thing you don't understand, you're not going to pass in your final. Okay, so I'm giving you guys a warning. I want you to really understand this. I'm explaining to you. The second time I'm repeating, you don't understand, come and have consultation with me. All right. And similarly, this P1 interrupt enabler, although you have a GIE, this interrupt enabler enables you to interrupt each individual pin as enabler for the interrupt. So if I change the value on that particular pin, it will enable the interrupt to happen. And this is the interrupt flag. Okay, so whenever that you did there is an interrupt, the flag will be on. All right, so in your code you need to reset this flag. All right, so I need you guys to actually study this one, very important. Study it in the book. Normally this PIE and PIES is it comes in a package. You have to. Now the more interesting question is, why this one 0, 1 and this one 1, 0? Because this is the button. Okay, this is the button. If you expand this equals to 0, 0, 0, 1. This is the 5th bit. All right, as the button. this flag is also a button. Only this guy is the connected to the LED. All right. Now, what if you configure this as 0x 0x00? Okay, obviously, it will not work. The LED will not work. Okay, if you some questions could be designed in such a way that he changed this value to 0x00. Then he will ask you, hey, why the LED is not blinking? You have to troubleshoot. Okay, so the question in such a way that is always referring to troubleshooting. That's why lab sessions is very important. Don't play around with the lab sessions. Sincerely do it, all right, yourself. All right. Which pin connected to the button? All right. So already give you just now the description. Okay, pin 5. If you expand 1 0, it will be 0 0 0 1 0 0 0. Okay, so pin number 5 is enabled. The rest are not enabled. Okay, why do you want to enable and disable? Because sometimes you do not want 2 pins to be enabled for interrupt. You know, you have you could have some peripherals, you know, connected to all these kind of other pins, and you do not want these peripherals to give a false alarm. All right. So this direction is only the first pin. It's 1. Okay, the rest is 0. Okay, so you only configure. Now, what happens if you configure the interrupt pin as an input, as an output? Now, let's say for example, P1 direction equals to 0x11. Will this button still work? The button will not work because you already configured the direction for button 5, for pin 5 as an output. So if it's an output, interrupt does not work. Okay, I really look back into whatever that I'm saying, repeat this video again and again, all right, and try to understand this section. Very important. Now, PXREN is not covered in this part of the tutorial, but I'd like you to just read yourself. There is a pull-up resistor configuration, pull-down resistor configuration. Means to say that you can configure that particular pin if normally is it 5 volt or normally is it 0 volt. Okay, if it's pull up, means to say that normally it's 5 volt. Once you activate it, okay, or you ground it, that particular pin becomes 0. Now, inversely, pull down configuration means normally is 0. Okay, once you pull it up to 5 volts, you connect the pin to 5 volts, then the pin become 5 volts. You can configure it using PXREN. PX can be 1, 2, 3, 4, 5. So in this case, X is 1. Okay, so please, I'm asking you again, this kind of thing, I'm repeating the second time. Don't play a fool with this thing. This is very basic. Okay. Now, P1ES. Okay. Now, P1 enabler, it's basically to enable the interrupt. Okay, if you disable this, let's say for example, I put this as 0x00. Can this code still work? The answer is no, the code will not work. All right. Now, what about P1IES? P1IES is basically to select the transition. Okay. Now, let's say for example, you apply a voltage. Okay, from low to high, only that part of the interrupt will happen. If you apply high to low, and you have to configure it as 1. If it's 0, you have to apply low to high transition. It only detects the edge. Okay, if that edge is detected, then this interrupt will happen. Okay, if the edge is not detected, the transition is not detected, this one does not happen. Okay, so whatever, when an interrupt happens, this part of the code is activated. All right. So when you have a transition, means to say that the user press the button, what will happen is that the part of the interrupt service routine will happen. Okay, and the flag will automatically on. Now, is this flag important? What if I ask, you know, what if I don't I don't configure this flag at all. Will the code still work? My answer is yes. Okay, so this last line is basically optional. Don't have this, the code will still blink the LED. But it's good practice to actually clear the flag every time there's an enable, because you can still use the flag for some other reasons, for checking or whatever. Okay, now please relook at this part, play this video again and again. This flag is basically to check the transition from low to high, from high to low. Means to say that if, let's say, there's a transition from 0 volt to 5 volt at that pin, the interrupt will happen. If you set this pin as 1, okay, means to say that this one is 0x, the fifth bit is on. The fifth bit is 1, means to say that the fifth bit uses the transition of high to low. Means to say that normally you would actually be 5 volts. When you press it, you'll be 0 volts. So you need to configure the pin manually as a pull up configuration. Okay, pull up configuration. Okay, so when you press it, okay, that switch this point will be grounded. So normally it's 5 volts. When you press it, it's 0. Okay, so you need to configure P1 IES to 1. Why? Because of this thing. Okay, now what if I want it to have a pull down resistor configuration? Okay, if I want to have a pull down resistor configuration, I will need to change this as 0. Okay, again, please repeat this video again and again. This one you have to understand. You don't understand this part, you will lose marks for your final. You believe me, mark my words, all right? Now, what about once you're interrupted, the pin number 5, it's configured in such a way, and the user press the button, okay, the LED will blink. Okay, the first pin will toggle. Now this is a symbol for toggle, means to say that whatever the value is, if previously it was 1, it will be toggled to 0. If it's 0, it will be toggled to 1. This is a symbol for toggle. Now this one means I already show you guys. This one means reset, bit masking reset. Means to say that you only want to reset the fifth pin, okay, the flag. Again, I don't have this, doesn't matter, it will still work. All right, so I already told you guys it will still work, but the code is designed in such a way. Okay, now question, change the code so that the LED connected to port 2 pin 5. Now LED is connected to port 2 pin 5, and the interrupt button is connected to port 2 pin 1. So this is something that could come out. Okay, there's a bit of mistake. Now this P1 out should be changed to P2 out, and this P1 IFG should be changed to P2 IFG. So I've mistakenly, I did not delete this, but I'm just saying, give you some homework so that you can understand this code. Again, okay, this one should be P2 out, P2 IFG. Okay, now why do I change this? Because it's no longer port 1, it's port 2. So you need to configure the port 2 direction. Everything you need to configure. Okay, sorry. This one is not P2 direction. This one is P2 IE, interrupt enable. Okay, so I'm enabling the port 1 to be the button. Port 1 to be the button. Everything the same, is still active high. It's still pull up configuration. Okay, I will connect this MCU. This one will be port 2. Port 2, okay, connected to the first pin. Okay, and the rest are connected to port 1. Okay, so the button is connected to port, whereas the LED is connected to port 5. So it's an inverse. All right, and this one will be changed to port 2 vector, port 2, and this one will be port 2 out, port 2 IFG. All right. So I hope that you repeat this video again and again. This kind of question very well can come out. I'm just giving you a warning. You have to understand this part by heart. All right. I give you guys some homework. Change the code based on the reference from the textbook. Activate using timer. All right. So I need you guys to this timer based interrupt. I want you guys to do investigation yourself. So you can interrupt it based on the IO. You can interrupt it based on the timer. When the timer is finish counting, it will activate the LED sequence, the blinking of the LED sequence, okay, such as this. So the timer, if you do timer, this part needs to change. This part is not important anymore. This part needs to change, okay. So the question can ask you, change this code such that it's a timer activated, okay. Now I want you guys to really sincerely go and do this question. I don't want to give you everything because give you everything you won't do, okay, and if you don't do, you won't go into your brain. All right, so this you have to understand, okay. This one is, I think, is in the lab also. I want you guys to actually go and investigate. This line particular enter low power mode, okay. We're not going to study this in depth, but seemingly this is just there, okay. Understand this part, okay. Now this line is the watchdog timer. I told you guys, you always code this first line. It's basically to disable the watchdog timer. If the question asks you what is this first line for, it's to disable the watchdog timer. Okay. So today we discuss about finally I'll give you the question, the answers with the comments. Okay. Stop watchdog timer, etc. 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 Okay, so this is the pin. It starts from pin 0. Pin 0 means the first pin. Okay, pin 4 means the fifth pin. Okay, it's just how they name it convention. Okay, so whether you name it after a 0 index or non-zero index is up to you. Doesn't matter. But what I want you to know today is basically revise back on the IO, the tutorials that I give you. This is bit masking set. This is bit masking reset. This is toggle. This is bit masking reset. Please study this. I give you a warning. All right. So thanks for spending time with the tutorial. I hope you guys enjoy doing some revision. Thank you.